Dear friends, good morning. Already we have seen how to solve a system using Cramer's method. Now we try to see how to solve a system using Matrix Inversion method. There are different methods to solve a system, of which matrix inversion is one among them. In the name itself, you are having matrix inversion. Means, to a matrix, you have to find inverse to get the solution. Let us move into the problem, how to solve the system using this method. Solve the system, particularly mentioned using matrix inversion method. As I said, before starting the problem, check whether X, Y, Z are in order and the other side you should have constants. One side you should have only X, Y, Z. On the other side you should have only the constants. If not, you have to arrange in that pattern. Right. Given system, I have copied the same here. Before going to the problem, we know how to write the matrices A, X, B. A matrix is formed with the coefficients of X, Y, Z. Coefficient of X is 1, Y 1. Coefficient of Z is also 1. So 1, 1, 1. In the second equation, coefficients of X, Y, Z are 2, 5, 7. In the third equation, they are 2, 1, minus 1. This matrix A is named as coefficient matrix because these are all coefficients of X, Y, Z. Now, matrix X is called variable matrix as you are going to find the values of the variables X, Y, Z. Matrix B is called constant matrix as 9, 52 and 0 are constants. First we check whether the system has a solution or not. So, we will check how to know the system has a solution. For that, find det A. Det A equal to, we know how to find a det. 1 into, remove row and column. The 4 elements, 5, 7, 1, minus 1. For the middle one, you have to change the sign, minus 1. The 4 elements left after removal of the row and column of 1, 2, 7, 2, minus 1. Plus 1 into removal of row and column, 2, 5, 2, 1. So 1 into AD minus BC of all these 2 by 2 debts, and the further simplification leads to det A equal to minus 4. If det A is 0, then system has no solution. System won't have a solution if det is 0. Here det is minus 4, which is not equal to 0. Hence system has a solution. System has solution. Suppose if in any one of the problem you get det A is 0, then without hesitating you can write system has no solution, no need to do further. Right. Now I identified that system has solution. How to find that solution? We need the values of x, y, z, no? X, y, z are in which matrix? Matrix X. X equal to, using this formula, we will find the values of x, y, z. What is 1 by det A into adjoint A? Actually that is A inverse. This is inverse of A. A inverse into B. To get the values of x, you have to use the formula 1 by det A into adjoint A into B, in which 1 by det A into adjoint A is nothing but inverse of A. You are finding inverse of A. In the name of the method you are having matrix inversion. So for matrix A you are finding inverse with which we can get the values of x, y, z. Hence the method named as matrix inversion method. Already we know det A, we calculated here. B matrix is already known. Now we try to find adjoint matrix. Adjoint matrix, to get adjoint you have to start with minor matrix. You have to start with minor matrix of A. How to write minor of A? For that I am writing again A here. 1, 1, 1, 2, 5, 7, 2, 1, minus 1. For each and every element of A, you have to find minor. How? Remove the element of row and column of 1. You are left with 4 elements. 5, 7, 1, minus 1. Likewise, for each and every element, you have to find minor. And you know how to find minor. In our previous videos, we have learned how to find minor of each and every element. With that, use the same concept to find minor of each and every element in the matrix A. So minor of 1, remove row and column. 4 elements, 2, 7, 2, minus 1. Minor of this one, remove row and column. 4 elements left are 2, 5, 2, 1. Minor of 2, 4 elements, 1, 1, 1, minus 1. Minor of 5, 1, 1, 2, minus 1. Likewise, you have to find minor of all the elements of matrix A. Now, find AD minus BC here. AD 5 into minus 1 is minus 5, minus BC minus 7. So this is minus 5 minus 7. This is minus 2 minus 14. 2 minus 10. Minus 1 minus 1. Minus 1 minus 2. 1 minus 2. Here 7 minus 5. 7 minus 2. 5 minus 2. Now, in the next step, we try to write the simplification of these elements. Minus 5 minus 7, minus 12, minus 16, minus 8, minus 2, minus 3, minus 1, 2, 5, 3. That is the simplification of minor matrix. So, minor matrix of A. Now, cofactor matrix. How to write cofactor matrix from the minor matrix? The diamond shaped elements are changed with its sign. The elements in these four places will change its symbol. Rest of the elements remains as it is. So minus 12. Since this is a diamond shaped element, it become minus 16 become plus 16, minus 8, minus 2 become plus 2, minus 3, minus 1 become plus 1, 2, minus 5, 3. This is a cofactor matrix. Adjoint matrix is nothing but it is a transpose of cofactor matrix. Transpose of cofactor matrix. We know how to transpose. Rows are interchanged to columns. So minus 12, 16, minus 8, the first column. Second row is changed to second column. Third row is changed to third column. This gives adjoint A. Now, we go to our actual formula. X equal to 1 by det A into adjoint A into B. All the three are known now. 1 by det A value minus 4. Adjoint A matrix already we have calculated here. The same. B means the constant matrix 952 0. You have to multiply these two matrices first. And we know multiplication is possible if number of columns in first matrix equal to number of rows in the second matrix. Since these two are equal, multiplication is possible. How to multiply? Row is multiplied to the column. So 1 by minus 4 remains as it is. Minus 12 into 9, minus 108, plus 2 into 52, 104, plus 2 into 0, 0. Now, second row, first column, the only column. 16 into 9, 144, plus minus 3 into 52, minus 156, minus 5 into 0, so minus 0. Third row, the column. Minus 8 into 9, minus 72, plus 1 into 52, 52, plus 0. Minus 108 plus 104 gives minus 4. 144 minus 156 is minus 12. Minus 72 plus 52 is minus 20. Now, multiply 1 by minus 4 inside. Minus gets cancelled, 4 fours cancel one time. 12 minus 12 by minus 4 gives 3. Minus 20 by minus 4. Minus cancel, 20 by 4 is 5. What is X? X is a column matrix X, Y, Z, that equal to 1, 3, 5. Two matrices are equal. Since these two orders are equal, corresponding elements are equal, so X equal to 1, Y equal to 3, Z equal to 5. This is our required solution. Like this, we try to solve the system using matrix inversion method. Problem is over.